Hey guys, I hope you all are doing good. In this lecture, we will be understanding what is proof by cases and solving questions on it, right? But before I start, I need to tell you about what is the importance of proof by cases, right? Throughout your computer science journey, it will be the case that a lot of problems that you come across, whether it's in coding or whether it's in general mathematics, in a lot of cases, we need to take a look at problems from the point of view where we need to take a look at different cases, right? Basically, look at different set of conditions and then solve the question or the problem for those separate conditions, right? Okay, so let's try to understand what is basically different cases. Proof by cases is when a statement is divided into different cases. If the statement holds in all possible cases, then the overall conclusion is valid, right? So the basic point is that I need to take a look at the statement. It might be the case that we are not able to directly reach the conclusion. Why? Because we need to take a look at different cases. One of the examples of different cases could be I need to take a look, figure out when the numbers are maybe even or when the numbers are odd, or maybe I need to solve or try to prove when the numbers are negative or the numbers are positive, right? Take a look at these different conditions. Okay, so now when I solve for these different conditions or different cases where it could be maybe number is negative and positive, then if I reach the conclusion that the statement is proven for both the cases, finally I can say that the overall conclusion is valid, right? So in short summary, I need to take a look at all the different cases, solve them, and reach the conclusion that I'm supposed to, and then combine all those conclusions together and say that I've reached the final conclusion, right? Yeah. So now let's try to understand when do we use proof by cases, right? So there are 2 points when the statement depends on different conditions. So just like I said, it could be the case that a statement is talking to you about different conditions that we need to look at. Maybe we need to consider the situation when the numbers are even or when the numbers are odd, or maybe I need to take a look at the conditions when the numbers are negative or numbers are positive, right? Okay. Secondly, when exhaustive enumeration is needed. This point is that when I need to take a look at different cases, that is what we basically mean by exhaustive enumeration, right? So taking a look at different cases, solving all those cases, and then trying to reach the conclusion. Yeah. So now, just the general structure of what is proof by cases, very important to understand once again. Keep this in mind, but once you keep solving more and more questions on proof by cases, then this will become a lot more clearer, right? So, first thing is identify all the possible cases. So, very important to understand. I'm taking a look at the problem and I need to understand what can be the possible cases that I need to look at, right? Should I look at negative number case and positive number cases? Or should I divide the situation into odd and even numbers? And there could be multiple or a lot of cases that we need to encounter, right? So the more questions you solve, the more you'll get an idea of which problem requires which kind of division or cases that we need to figure out. So first thing is identify all cases. This is probably the most difficult part, if I should say. Then prove the statement separately for each of the cases, right? So need to prove for maybe when the numbers are odd or maybe when the numbers are even, right? And then finally conclude that the statement holds universally. Universally over here means that it holds for the entire thing that we were trying to prove, right? Okay, now let's take a look at two different examples and I think it will make things a lot more clear. Okay, so now let's take a look at two different examples. Uh, these are going to be very easy to understand. The basic point is that we need to understand what are the different cases, right? Okay, so let's start with example one. Proof for any integer n square when divided by 4 leaves a remainder 0 or 1. So we basically represent this as n mod 4 equal 0 or 1, right? So what is the basic point? I'm supposed to prove that there's a value integer n. When I square it and when I divide that square by 4, it has to be that either the number results in a 0 or that results in a 1, right? The remainder is 0 or 1. So now let's try to understand why do we need different cases, right? If you think about it, there's no one situation in this case. It's not the fact that for all numbers this equation behaves the same way or this question behaves the same way. The problem is that there are some cases, and the fact is that for this question we need to cover two different cases, which is for even numbers this question behaves in a different way, and for odd numbers it behaves in a different way, right? So let's try to understand how do we solve it by different cases, right? So first thing, I need to identify different cases, right? So I'm going to write down the different cases. One, which is when n is even, right? And the second case is, right, I'm writing it down over here, when n is odd. So let's try to simultaneously solve both these parts, right? First thing is, when n is even, then you know it's of the form 2k, right? And when n is odd, then it is of the form 2k plus 1, right? If you don't understand how I'm representing this as 2k or this as 2k plus 1, I would suggest that you can look at my previous video where I've introduced these concepts, right? Okay. So when n is even, then it is of the form 2k, and when n is odd, it is of the form 2k plus 1, where k is an integer. So this was the first thing that I had to do, right? Identify all the possible cases. I identified them. I realized that there are different cases, and in this case, this question, this problem behaves differently for when the numbers are odd or when the numbers are even, right? Okay. So now let's try to solve for it, right? N square is going to be 4k square in this case, right? And n square is going to be 4k square plus 4k plus 1 in this case. Now what I'm supposed to prove is that when divided by 4, it leaves the remainder 0 or 1. The point is that it has to be either 0 or the value 1. It cannot be the case that it leaves any other remainder value. So let's think about it, right? When even, n square is 4k square. Now think about it, right? There's already a value 4. Then that means 4k square when divided by 4. Since it's already a multiple of 4, then it has to be that it leaves the remainder 0. Right? I hope you're able to understand it, right? N square is 4k square, so 4k square when divided by 4 has to leave the remainder 0, right? I'm not using the mathematical representations in this case, just so that you're able to understand what I'm trying to do, right? Okay. So when n is odd, then n square is 4k square plus 4k plus 1. What is this representation? Once again, I can write it as n square equal 4 common k square plus k plus 1. Now think about it, right? This is basically a number which is divisible by 4 plus adding a 1 to it. So think about it. This part, which is 4k square plus k, this part should be divisible by 4, right? But there's a 1 to it. That basically means that the remainder remaining should be 1, right? So in this case, n square is by 4 right? So now once again, if you take a look at consider both these cases, the point is that both of them behave in a different way. When the numbers are even, right, then the remainder is 0, and when the numbers are odd, that the remainder is 1. So there are different cases, right? And that is exactly what we identified. So the final part is that when number is even, right, remainder is 0. When number is odd, the remainder is 1. I don't think there are any other cases that I need to consider. It was just when the numbers are even or the numbers are odd, right? So finally, since I know for numbers even and for numbers odd, the remainder is either 0 or 1. Hence, from cases 1 and 2, we have proved. I'm not writing down the entire statement, but it basically means we have proved that for every integer n square when divided by 4 leaves remainder 0 or 1. Yeah. Once again, one more point. I might have missed some definitions in this case, right? But make sure that whenever you are writing down proofs, you explain every single point and every single new detail that you add. So if you introduce a new variable, let's say in this case k, right, or any new thing, you need to let somebody who reads it understand what you exactly mean, right? Okay. Now let's take a look at the second example. So proof for all x which are elements of the real numbers, the absolute value of x plus x is greater than equal to 0, right? Okay. So I'm considering all the real numbers and I need to prove that absolute value of x plus x is greater than equal to 0. Now, very important point to understand once again is, let's first try to understand what is the absolute value, right? Absolute value basically means that whenever there's a value, let's say x is 0, x is 1, then the absolute value would be 1. So absolute value of 1 is 1, and the absolute value of -1 is going to be 1 again. So absolute basically converts the value into its positive value, right? It doesn't do any opposite way, right? 1 is not converted to -1, but if it sees a negative value, then it will convert it into a positive value, right? Okay. So now one more important point to understand in this case is, so if x is positive, then modulus of x, or sorry, I should say absolute value of x is going to be x, right? You understand it? So if x is 4 or 5 or 6, then absolute value of it is going to be 4 or 5 or 6. But if x is negative, then absolute value of x is going to be negative of x. Let's try to understand this point, or what do I mean by that, right? What I'm saying is, absolute value of x is going to be the positive of it, and if you apply a negative sign to a negative value, then that converts it into a positive value, right? So think about this. Absolute value of -4 is equal to negative of -4, which is equal to 4 in this case, and this is what we exactly mean. So if x is positive, then absolute value of x is x, and if x is negative, then the absolute value is equal to negative x. This is just a general thing that you need to understand, and I think this will be very helpful in future cases as well. So now let's try to solve this question. By now you probably understand what are the different cases that we are looking at, right? In this case, I don't think knowing if I take a look at different cases, right? Let's say I'm thinking maybe I should look at the cases even or odd. I'll find out that that is not going to be very interesting and that is not going to really help me out, right? In this case, the cases that I need to look at is going to be when the numbers are less than 0 or equal to 0 or greater than 0. And I know this might seem like, how do we identify cases? It is going to be the case that, just like I said, the more problems you solve, the better you get at understanding uh, what kind of cases that I need to look at, right? So for me, I understand that the cases that we need to look at are when the values are less than 0, when the value is equal to 0, and when the value is greater than 0. Why I'm looking at it is the fact that this question or this equation is going to behave differently for all these different cases, right? So let's take a look at all the cases that we have. So case 1, x is greater than 0. So let's take a look at when x is greater than 0. For all the cases, I'm supposed to prove that absolute value of x plus x is greater than 0, right? So think about it, right? When x is odd, sorry, x is positive number, then this should basically mean x plus x, right? Which is equal to 2 of x. Now think about it, right? X is a positive value. Absolute value of x is going to be equal to x because it is positive. And if I add x once again, it results in 2x. So it's basically 2 times the positive value. Since already x is greater than 0, then 2x should also be greater than 0, right? So since for Okay, once again, I've written this definition. This is just an explanation I've written down, not something that you have to write in a proof. You just have to prove the point For example, in this case, I've proved this is 2x, which is greater than equal to 0, right? And that's the single point I had to prove. But I've written down this point that since this value is 2x, which is greater than 0, then this equation is going to be true for this case, right? Okay, now let's take a look at the second case, which is when x is equal to 0. Okay, when x is equal to 0, think about it, right? Absolute value of x plus x is going to be 0 plus 0, which is equal to 0. And this value is greater than equal to 0, right? So case 2 is true, case 1 is true. I've considered when x is greater than 0 and when x is equal to 2. Now let's take a look at the final condition, right? Now this is the most interesting case in this example. When x is less than 0, then absolute value of x plus x, what would it be, right? Since I've been given that x is less than 0, then it has to be that the absolute value of x is actually the negative of the value x. Think about it, right? If the value is negative 4, then the absolute value of 4, which is basically meaning it is negative of negative 4, right? Which converts it into a positive value. So absolute value of x when x is less than 0 is going to be negative of x. This means that this is going to be negative x plus x, which is actually equal to 0, right? So in this case also, this is less than, I should say, this is greater than equal to 0 in this case, right? So I looked at all the different cases when it's greater than 0, when it's equal to 0, and when it's less than 0, right? If you notice, then the equation behaves differently for all of them, right? And hence, finally, I've proved that since it's true for all those cases, right? Finally, I just have to write down that since we have proved for all different cases, and hence universally, absolute value of x plus x is greater than equal to 0, right? So I'll leave that task up to you guys to write down the final statement. Now, I hope you were able to understand how proof by cases works from these two examples. Now, I'll be giving a bunch of practice questions for you guys to solve, and I really hope you guys would solve those questions, and I think it would be a good practice. So let's go ahead with the practice questions. Okay, so I've given two questions on the board which are supposed to be solved by proof by cases, right? I've given some hints as well, just for help. In reality, you'll encounter most of the questions have a very similar structure, so these should be very easy to understand, right? Now, I really hope you're able to solve these questions. I'll enter the answers in the description, and I'll see you guys in the next lecture.